So laws of indices come in handy with this. Two in particular worth adding to your table of standard derivatives, these two laws of indices, for roots and for inverse functions. So let's look at a couple of examples. Say I wanted to differentiate st equals the square root of t cubed, and I've got, say, Vt, instantaneous voltage, equals 3 over 4t squared. I want to differentiate those two. The first thing I do is rewrite these two. I'm not differentiating yet. St is still equal to this, but I rewrite it in power form. So I remember the law of indices, and it tells me that's t to the power 3 over 2, because it's the square root. And I remember this is 3 over 4 times 1 over t squared. If you think about it, you can separate those two out, which is the same as 3/4 of t to the minus 2. Now that's not dead straightforward, and that's where the difficulty starts with the calculus. It's not the rule, it's the algebra. I will have to use these laws of indices to rewrite those functions in that form. Just write those down and check you see where they come from. So now I've rewritten my two functions in power form, I can apply the rule. And the rule I'm going to apply is the top one. This one here. Ax to the n. N is the power, a is the number in front. So with this rule in mind, that's the rule. I look at my power, 3/2, and I take one off it. 3 over 2 take away 1, and this is something else we have to be aware of, thinking about subtracting fractions here. 3 over 2 take away 1. Think of the 3 over 2, or sorry, think of the 1 as 2/2, and this applies to all fraction ones. 3/2 take away 2/2 is 1/2. So the power, the differential of s, which is s prime t, equals t to the power 1/2. Oh, it's got a bit messy now. T to the power 1/2. Let's get rid of that. And what's the number in front? Well, before I differentiate it, the number in front is just 1. So I'll bring the 3 over 2, the power out, and put it in front and multiply it by a. So 1 times 3/2 is just 3/2. So 3/2 t to the 1/2 would be the answer. And you've written it down, just check you see it. I could, if I wanted to, now rewrite this in surd form, in root form, and call that 3/2 times the square root of t, because t to the power 1/2 is the square root. So it's the algebra now we're starting to get into. The rule is the easy bit of the problem. If we look at the next one, if I'm going to differentiate this one, v prime t will equal, same rule. Bring the power down, the power is minus 2, and multiply that by the number in front. Minus 2 times 3/4 is minus 8/4. Sorry, what am I saying? How did I get 8? Minus 2 times 2 is minus 6/4. Goodness knows what happened there. And then t to the power, well, minus 2 take away 1, minus 3. Minus 2 minus 1 is minus 3. I can tidy this up a bit, because 6 over 4 becomes 3 over 2, and over becomes 1 over t cubed, so I can rewrite that as minus 3 over 2t cubed if I wanted to get it in the same form as the original function was in. But you know, this is just algebra, isn't it? So that's where it starts to get a bit awkward. Many of the functions that we're interested in don't end up being awkward things like this, but you need to know how they work. So I'll stop this now and have a go at some of the exercises in the textbook. If you go to the website and have a look, you'll see some solutions. I've put loads of solutions to the exercise on differential calculus in there, in the Maths at Low Stuff College site. So what we need to do now is just have a go at some.